Citroën dealer. We are happy to help you with the diagnosis, repair plan, or maintenance of a new or used Citroën and are ready for maintenance, repair, damage repair, or one of our other services. Welcome to Care Repair Forum. Citroën PRTS. By replacing or repairing parts on your Citroën in a timely manner, your car remains in top condition. We have everything you need to keep your car reliable and safe, from large parts to small lights. Citroën is recalling certain C3 and DS3 models from 2009 to 2019 due to a possible defect in the airbags from manufacturer Takata. In the event of a collision, the airbag may open with too much force, causing metal particles to be released. This poses a safety risk. When we receive the airbags, which will be the case soon, we will create space in our workshop planner. Leave your details, and we will contact you as soon as the airbags have arrived to schedule an appointment in our workshop. This way we can serve you as quickly as possible. What else can you expect? You will receive a letter from Citroën with further information. Only C3 and DS3 models with a certain Takata airbag are affected by this recall. The replacement is completely free of charge. It is possible to wait during the repair. This takes just over an hour. Team of professional employees is ready to assist you after purchasing your new or second-hand Citroën. You can contact us for maintenance, repairs, tires, MOT, minor and major service, replacing brakes, replacing timing belt, air conditioning service, replacing clutch, changing oil, replacing oil filter, installing tow bar, winter check, summer check, and replacing the battery. We maintain and repair your car, but also supply official brand parts and accessories. Citroën dealer. Citroën C3. 1.6 e-HDi collection. Engine code 9H06. 4-cylinder, 1660 cc. Diesel. Year of construction, 2012. Complaint description. Engine sometimes drops and no pulling power. After clearing the error code, it drives fine again temporarily. Error message has to do with oil pressure and filter. Exhaust pipe is nice and gray, so combustion seems neat. With this engine and complaint, a known culprit is the lubrication and oil pressure system, including oil suction strainer and oil pressure control valve, and the connection to the turbo lubrication, and sometimes the camshaft adjustment. Diagnosis and repair plan for the mechanic. First step error codes and live data. Read car with brand-specific diagnosis, not just universal OBD. Pay attention to error codes. Engine control unit. Oil pressure and lubrication system. Turbo control. Fuel system rail pressure. Record codes with status. Permanent. Temporary. History. Live data during idle and under load. Measured oil pressure, if there is a pressure sensor. Oil pressure switch status. Turbo load, and required versus measured pressure. Fuel rail pressure, requested versus measured. Engine temperature. If there is a specific error code for oil pressure or clogged oil filter, and or pressure control valve, record code and manufacturer's description. Second step checking oil and maintenance history. Ask and check. When was the oil last changed, and with what specification? Has the correct low S, a PS type, been used in accordance with factory instructions? How many kilometers since last oil change? The car has driven many short distances. Oil level and condition. Check dipstick. Assess oil color and viscosity. Check for fuel dilution and strong burnt oil odor. In case of doubt or maintenance unknown, plan immediately. Oil flushing if justified. New oil filter. New engine oil, according to specifications. Third step, mechanical control lubrication system. Measuring oil pressure with a mechanical meter. Remove switch and install mechanical oil pressure gauge. Measure with a warm engine at idle and at increased speed. Compare with factory specification. If oil pressure is too low, remove oil pan. Check the suction strainer for contamination by sludge, carbon, metal particles. Check the oil pump for wear of gears and play. Inspect suction tube O-ring and seals. Clean or replace. Suction strainer if dirty. Oil pump if in doubt about capacity. Gaskets and seals. Oil pressure control valve and any filters. With this engine, small filters and channels to the turbo and camshaft adjustment can become clogged. Dismantle the valve and check for contamination and sticking. If necessary, replace with a new part. Fourth step relationship with emergency running and loss of traction. The engine control unit goes into emergency mode if the oil pressure is low or questionable. Speed limitation. Turbo is adjusted back. Therefore, no traction force and interference that sometimes disappears after a racing, but returns if the pressure is not sufficient again. Check whether a complaint occurs. Oil pressure value in live data disappears or becomes too low. Sometimes the sensor switches and puts the ECU motor in safe mode, while mechanical pressure is still just within spec, but the sensor or wiring gives a false signal. That's why. Check oil pressure sensor and wiring. Corrosion plug. Cable break. Contact resistance. Fifth step, checking turbo and fuel system. Because the complaint can also be ignition, emergency running with turbo or fuel problems, it is wise to check at the same time. Turbo. Check vacuum or electronic control depending on type. Check fixed parts and wastegate or variable geometry for ease of use. Inspect the intake and exhaust sides for oil and shaft play. Fuel system. Rail pressure during complaint. If rail pressure also drops, the ECU can trigger multiple protections simultaneously. Check fuel filter date and contamination. Test return injector, leaks if necessary. Sixth step, check EGR and particulate filter. Although the exhaust is gray, and that usually indicates a properly functioning particulate filter and combustion, still check it. Note error codes for EGR and FAP or DPF. Check the differential pressure sensor of the particulate filter. EGR valve position, requested versus measured in live data. In the event of a serious blockage of the particulate filter, the ECU can also reduce engine power, but then you often see black soot blobs or error codes for the particulate filter. Seventh step, electrical and sensor technical check. In addition to oil pressure sensor, also check crankshaft sensor and camshaft sensor, because incorrect timing information can also cause emergency running. Check wiring along engine block for abrasions and heat damage. Clean and secure engine and body ground points. Instrument panel control and warnings. Is there an oil pressure light or only an engine malfunction light? This helps estimate whether it is a mechanical problem or mainly ECU and sensor related. Concrete repair approach in sequence. Step 1. Accurate diagnosis with original or good brand-specific tester. Save error codes for file and check again after repair. Step 2. Oil change with flushing if justified. Old filter out. Inspect the drain plug for metal shavings. New oil according to Citroën specification and new filter. Step 3. Perform mechanical oil pressure measurement. If busy, good. Focus on sensor and wiring. Oil pressure sensor replaced with original quality. Check plug and wiring harness and repair if necessary. If busy, bad. Remove the oil pan. Clean or replace the suction strainer. Inspect oil pump and replace if necessary. Clean or replace the oil pressure control valve and any filters in the block. Step 4. Check turbo oil line. Dismantle supply and drain pipes and check for blockages and boiling oil residues. If dirty, install new pipes and check turbo for play and damage. Step 5. Test drive with live data logging. Oil pressure, turbo pressure, rail pressure, If no fault returns and values remain in spec, the repair has been successful. Step 6. Advise customer on maintenance interval. These engines require strict oil changes, preferably every 15,000 kilometers or 1 year. Don't wait for long extended intervals. Known problems with this engine and type. Common problems: siltation and sludge in the lubrication system if oil change intervals are too long. Blockage of oil pipes to turbo. Accelerated turbo wear. Lower oil pressure and emergency running. Vulnerable parts: oil pressure sensor, oil pump suction strainer, turbo oil line, injectors, and EGR valve for bad diesel or short journeys. Recommended approach for unknown mileage or high mileage. At well over 120,000 kilometers and no demonstrable good maintenance history. Always minimal. Carter off. Check suction strainer. Check oil lines to turbo. New oil with correct spec. Check sensors. Cost indication in words. An oil change with a good filter for this car is usually between 100 and 200 euros, depending on oil and hourly rate. Remove the oil pan and clean or replace the suction strainer plus new oil and gaskets. Calculate roughly between 300 and 600 euros for a normal hourly wage. Replacing the oil pump can bring the total closer to 500 to 900 euros, depending on parts prices and extra work. Replace oil pressure sensor and repair wiring, usually between 100 and 300 euros. Turbo replacement, if it is also damaged, quickly runs towards 1,000 to 2,500 euros, including oil pipes and labor. Prevention future. Short maintenance intervals. Oil every 10,000 miles or sooner for many short trips. Always correct oil specification. Never take cheap universal stuff. Always replace the oil filter on time. Do not use flushing agents without necessity. An extra oil change is preferable to aggressive flushing agents in an engine with possible sludge. Build up slowly when the engine is cold. No high loads for the first kilometers so that the oil gradually reaches pressure and temperature. Summary work plan. Correctly read and record error codes and live data. Oil change and filter with correct specification. Mechanical oil pressure measurement. If there is any deviation, remove the oil pan and check and repair the suction strainer, oil pump and control valve. Check oil pressure sensor and wiring and replace if necessary. Check and clean or replace turbo oil lines. Test drive with logging. Service advice to customer about shorter oil change, interval and correct oil. This way, you specifically tackle the cause of oil pressure-related emergency running and prevent the problem from recurring. Citroën C3 1.6 e-HDi with engine code 9H06. This is a known sensitive block. The complaint and error about oil pressure correspond to typical wear and contamination of the lubrication system and turbo lubrication. I'll split it into 3 points. Why it breaks. What you should do now. How to prevent it as much as possible in the future. Why this breaks. Main causes. 2. Long oil change intervals. Oil ages and thickens. Sludge and char build up in the block. Suction strainer and crankcase is becoming increasingly clogged. Oil passages and filters to the turbo and camshaft adjustment become clogged. Consequence. Oil pressure drops, especially when warm and under load. ECU get too low oil pressure and throw the engine into limp mode, so no traction. Wrong or too cheap oil. This type of engine requires oil with a specific standard and low SAPS. If oil with the wrong specification is used, forms sludge faster and burns sooner. This accelerates constipation. Suction strainer. Oil channels. Filters in the oil supply to the turbo. Many short journeys and often cold engines. Motor oil does not reach the correct temperature during short distances. Fuel and moisture remain suspended in the oil. Oil dilutes and contaminates more quickly. Sludge builds up in sump and strainer. At higher loads, lubrication is insufficient. Turbo oil supply and return. In this engine, the turbo is highly dependent on good oil flow. If strainers and pipes are partially clogged, turbo is getting too little oil. Oil burns in the turbo. Residues return to the system. Even more pollution and risk of turbo damage. Oil pressure sensor and sensor circuits. Sensors themselves can also become old or unreliable. They see real low pressure or give false alarms. Both cases lead to emergency running and loss of power. What should you do now to get the problems under control? Goal is: make sure that the actual oil pressure is correct and the system is clean enough, and that the ECU sees the correct signal. Practical steps for you as a mechanic. Really measure oil pressure. Connect mechanical gauge at the location of the oil pressure sensor. Measure with a warm engine at idle and at increased speed. If this measurement is incorrect, you have a real lubrication problem and not a pure sensor error. Remove the oil pan and check the suction strainer. When in doubt or low pressure, remove the oil pan. Inspect the suction strainer for sludge and residue. Clean thoroughly or replace if necessary. Check oil pump and suction pipe seals. This prevents the pump from sucking in air and losing pressure. Clean the oil system sensibly. Don't throw harsh chemical spool junk into an old and possibly worn-out engine. Better, mechanical cleaning that you can reach. Carter, sieve, pipes, then fresh oil and filter. After a short time, for example, change it again 1,000 to 2,000 kilometers to remove residual contamination. Check oil pressure sensor and wiring harness. Replace sensor with good quality one. Check plug and cable for corrosion or breakage. This way, you prevent false alarms that cause emergency situations. Check turbo oil supply and drain lines. Dismantle pipes. Check to see if they are caked internally. If there is deposits or blockage, replace pipes. Turbo bearing clearance check and visual inspection. If the turbo is seriously damaged, it must also be addressed. Not so. In any case, ensure that the oil flow can pass through it properly again after repair. Test drive with live data. After the above work, check oil pressure value or pressure status and turbo operation in live data. Under load, check whether emergency running no longer occurs. How do you prevent problems in the future? This is where the real gain lies. The engine can last quite a long time if the lubrication system is treated properly from now on. Shorter and strict oil change intervals. No waiting for long factory intervals. Guideline for this block: oil and filter every 10,000 miles or 1 year. For many short journeys, preferably earlier. Why? Because fresh oil forms less sludge. The chance of clogging of the sieve and channels is much smaller. Turbo and bearings better protected. Always use the correct oil. Only oil that meets the standard prescribed by the manufacturer. Low SAPS and correct viscosity. No universal cheap oil. Why? The additive package and the correct oil is tailored to this type of diesel with particulate filter and fine channels. Wrong oil burns faster, leaves more deposits, and clogs the system faster. Don't wait too long with filters. Replace oil filter with every oil chain. Fuel filter according to schedule, but preferably a little earlier if in doubt. Why? A clogged filter puts the entire system under extra load, especially during cold starts and high loads. Driving style and use. Handle a cold engine calmly. Drive quietly for the first kilometers. No full throttle. No high revs. So that oil gradually reaches pressure and temperature. Long highway rides do the engine good. Means more long rides. Less condensation in oil. less fuel dilution, less sludge formation. Avoid structurally very short journeys. If the car mainly drives short distances, advise the customer. Occasionally, take a longer ride. At least once a week or every 2 weeks. This is especially important for diesel with a particulate filter. Regular inspection by the technician at every turn, and preferably every time the car comes onto the bridge. Check oil level. Detect any oil leaks. Listening on turbo whistle or bearing sounds. Scan fault memory, even if the fault lamp is not lit. Better to spot an initial problem early than wait for emergency running and hard mechanical damage. Why else will it break again if you don't change anything? If you only delete the error code and do not determine the cause, the sieve continues to slowly clog up. Do channels and pipes remain dirty? Oil pressure is dropping more and more often. A combination of low oil pressure and poor lubrication ultimately causes wear on bearings, turbo damage, possible engine damage, such as bearing damage to crankshaft. So, the basic cause is contamination and wear due to long intervals and sometimes the wrong oil. The current approach is to make the system mechanically and functionally healthy again. Future prevention is short intervals, right oil, calm cold driving style, and periodic inspection. Citroën C3 1.6 e-HDi collection. Engine code 9H06. Diesel. Workshop plan of 4. Problem oil pressure failure and sometimes no pulling power. Part 1. Immediate diagnosis and repair. 1. Error codes and live data. Read the car with a brand-specific tester. Save and print all error codes. During engine check. Oil pressure related. Turbo pressure. Rail pressure. Check coolant temperature in live data. 2. Measuring oil pressure mechanically. Remove oil pressure sensor. Install mechanical oil pressure gauge. With warm engine. Stationary. Measure 2,500 to 3,000 revolutions. Compare with specification. 3. Decision based on oil pressure. If oil pressure is within specification, replace oil pressure sensor with good quality one. Check plug and wiring harness visually and electrically. Clean contact points. Fill with new oil and new oil filter with correct specification. If oil pressure is too low, remove the oil pan. Check the suction strainer for sludge and dirt. Clean or replace the strainer. Check oil pump and suction pipe seals. Replace oil pump and seals if necessary. Remove and clean or replace the oil pressure control valve and any filters. Fill with new oil and new filter of correct specification. 4. Turbo oil supply and return. Dismantle supply and return pipes. Check internal blockage. Replace pipes if dirty. Check turbo shaft play and damage. 5. Final inspection and test drive. Clear system with tester. Warm up the engine. Test drive with live data. Oil pressure status. Turbo pressure. Follow rail pressure. Check whether emergency running and error codes do not return. Part 2. Prevention plan for the future. 1. Oil change policy. Oil and filter every 10,000 miles or once a year. Recommend sooner for mainly short journeys. Only use oil according to Citroën specification for this engine. 2. Filter maintenance. New oil filter with every oil change. Fuel filter according to schedule, but preferably do not let it run out. If in doubt, replace the fuel filter sooner. 3. Driving advice customer. When the engine is cold, drive slowly and avoid high revs. Where possible, regular longer journeys. No use only for very short pieces. 4. Periodic inspection in workshop. At every turn. Check oil level. Check for leaks around engine and turbo. Visual inspection of turbo oil pipes. Read engine fault memory, even without fault lamp. 5. Document. Place work performed and oil specification on invoice and in workshop file. Record mileage in words when changing oil. With this plan, first ensure the oil pressure and lubrication system are technically in order. Then use short intervals and the correct oil. The problem remains under control as best as possible. Citroën C3. C3, 1.6 e-HDi collection. License plate NE752 DPO. Engine code 9H06, 1560 cc, 4 cylinders. Fuel diesel. Manual front-wheel drive. Diagnosis and repair plan of a garage mechanic focused on fuel system and engine. General known, Citroën C3 1.6 e-HDi 9H06. Fuel diesel. Transmission, usually 5 or 6-speed manual. Front-wheel drive. Years of construction relevant from 2009 to 2015 for this generation. Engine types related. e-HDi 16. Different power variants between approximately 75 and 110 pk. Known issues. Common problems with this type of engine, e.g. valve contamination and sticking. Intake path contamination by soot and oil vapor, including intake duct and intake manifold. Turbo oil leak worn bearing, seizing variable geometry. Particulate filter DPF blockage, back pressure too high, forced regenerations. Injectors leakage on return internal atomization, pattern deviating. Leaky atomizer copper rings, black deposits around the atomizer. Fuel leak from high-pressure pipes or return pipes. Glow plugs and glow relays malfunction, especially during cold starts. Timing belt wear, fluid or oil contamination often exceeds the interval. Crankshaft pulley damper rubber loose, vibration and noise. Cooling system small leaks at connections and thermostat housing. Malfunctions and recalls based on known internet images. Faults in engine control software with DPF and EGR control. Sometimes recalls or service actions for software update DPF control times. Known risk of premature turbo damage due to neglected oil and filters. Vulnerable parts. Turbo and oil line to turbo. EGR valve and EGR cooler. Particulate filter. Injectors copper sealing rings return lines. Plastic crankcase breather can crack or become clogged. Crankshaft pulley. Engine mounts. Recommended construction years and versions. The engine runs well if the oil and filters are done on time. Prefer cars with demonstrable dealer or specialist maintenance. Avoid cars without evidence of timely timing belt and water pump replacement. At high mileages above 200,000, check turbo history and DPF condition. Diagnosis general. Diagnostic step sequence. Visual inspection of engine compartment, leaks, loose plugs, brakes and hoses. Read out engine control with diagnostic device. View freeze frame data for error codes. Basic checks oil level, coolant level, fuel filter, air filter quality. Test drive with live data monitoring rail pressure, turbo air mass pressure, EGR position DPF pressure. Mechanical check, where necessary compression leakage test, turbo damage inspection. Common malfunctions. Engine failure reports, power limited. Smoke black when accelerating, white or blue when using oil. Troubleshooting turbo emergency running. Jerky running when the engine is cold. Poor cold start especially at low temperatures. High DPF back pressure, often in combination with many short journeys. Diagnostic equipment. Diagbox or comparable P.S. a suitable diagnostic device. Universal OBD reader with live data and possibility of DPF and EGR monitoring. Multimeter. Oscilloscope for in-depth diagnosis of injection signals. Fuel pressure gauge for low-pressure side tank pump. Smoke machine for inlet and vacuum leakage. Mechanical pressure set for compression. Manometer DPF pressure before and after filter. Electrical fault steps. Check battery voltage and ground connections. Measure alternator charging voltage. Check fuses and motor control relays. Read error codes with the diagnostic device, clear status, see which ones come back. Check wiring around rail pressure sensor, air mass meter, turbo pressure sensor, and EGR. If necessary, clean the plug contacts with contact spray. Error codes. Typical for fuel system and engine. Rail pressure too low or too high. EGR position error. Turbo boost pressure deviation. Glow plug malfunction cylinder. DPF, soot level high or differential pressure high value. Engine diagnosis. Check mechanical wear. Listening to tapping sounds especially cold. Irregular idling speed. Check oil consumption for any bluish smoke. If in doubt, measure oil pressure. Checking the crankcase ventilation. Excess pressure may indicate blow-by. Endoscopy via glow plug or injector hole if cylinder damage is suspected. Measure compression. Remove glow plugs. Use a special diesel compression, measurings. Bring engine to operating temperature for measurement. Maintain minimum compression value and maximum difference between cylinders according to factory. Compression too low possible. Piston rings, valves, head gasket. Turbo and injectors. Turbo. Remove the inlet pipe and check the radial and axial clearance with the engine at a standstill. Check turbo impellers for damage. Assess oil in intercooler line. Light film normal, oil puddles not normal. Search for leaks in the boost circuit under vacuum and pressure. Compare live data boost pressure versus calculated target values. Injectors. Return leak test with measuring cups. Check correction values per cylinder in the diagnostic device. In case of hard diesel knock or misfire, have the cylinder injection pattern tested by a specialist. Check the fuel rail and high-pressure pump for metal particles when flushing iron particles and replace parts. Cooling system. Visual check for leaks around water pump thermostat, housing radiator hoses. Pressure test on cooling system. Check fan switch on time and operation. Check thermostat opening temperature via live data. Check head gasket or white sludge in oil for possible head gasket problems. Recognizing early engine damage. Metal glitter in oil and filter. Under pressure or overpressure crankcase very different. Clap or knock when the engine is warm and under load. Structurally low oil pressure. Turbo with a lot of axial play. Diagnosis drive and gearbox. Gearbox problems. Difficult to shift, especially second and reverse. Noises during certain acceleration. Leaks from drive shaft seals. Looseness in shift cables or gear lever mechanism. Manual transmission. Check oil level via filler plug. Assess metal particles on magnet and in oil. Check the clutch for slippage and engagement point. Check clutch cylinders and pipes for leaks. Maintenance. Change the manual gearbox oil every approximately 150,000 kilometers, even if the manufacturer indicates lifetime. Replace clutch and pressure plate in case of slippage or heavy shifting, in combination with a high engagement point. Drive shafts and CV joints. Check for cracks in rubber covers. Test play by moving shaft with hand. Clicking noises when cornering indicate outer CV joint wear. If necessary, replace the complete axle if there is play or noise. Chassis and brakes diagnosis. Check shock absorbers. Visually check for leaks. Assess car impressions after vibration. Irregular tire where can indicate poor cushioning. Brake components. Measure thickness of brake pads and discs. Assess rust lip on disc. Brake hoses on drought cracks. Check handbrake operation and cables. Problems with braking. Crooked discs often vibrate when braking. Skew difference in braking force left-right. Soft pedal pressure, possible air or leakage. Steering system. Play on ball joints, track rods and steering ball joints. Dust covers on wheelhouse. Alignment after replacing steering or suspension parts. Electronics diagnostics. Electronic disturbances. Comfort disturbances such as windows closed. Lighting are often caused by door cable breakage. Check ground points in engine compartment and under dashboard. Battery and alternator control. Battery voltage at rest measure approximately 12.6 volts desired. Starting voltage not below approximately 9 volts. Charging voltage around 14 volts with the engine running. Charging current test at heavy load. Instrument panel and comfort electronics. Readout test with body computer diagnostic device. Checking for water intrusion at fuse boxes. Repair and repair plan. Draw up a repair plan. Record the customer's complaint description. When does the cold, warm speed occur? Read and record error codes with freeze frame. Test drive with live data to reproduce complaint. Systematically exclude fuel air, exhaust DPFEG, are mechanically per system. Make a quotation with the division of labor and parts, including possible additional costs for dismantling fines. Prioritize inspection and replacement. First, safety brakes, handlebar tires. Then engine protection work, oil leakage, distribution cooling. Then malfunctions that affect power and consumption, e.g. RDPF turbo injectors. Finally, comfort and non-critical electronics. Urgent replacements for this type. Timing belt and water pump according to interval, or if in doubt, do it immediately. Oil and filter, at least every 15,000 kilometers, or 1 year. In case of turbo noise or high oil consumption, inspect the turbo and oil supply and return line and replace together if necessary. Address leaking injector seals immediately to prevent burn-in in the cylinder head. Original versus imitation parts. For distribution, set water pump injectors turbo and DPF preference for original or a brand. Good aftermarket, a brand acceptable for filters, brakes, and suspension. Avoid cheap unknown turbos and injectors. Costs of parts and labor, global target prices. Average parts prices. Oil and filter between 150 and 200 euros including oil. Air and fuel filter set around 100 euros. Distribution set with water pump between 400 and 700 euro parts. Turbo overhaul or exchange between 700 and 1200 euro parts. Atomizer per piece exchange between 300 and 500 euros. DP F exchange part between 800 and 1500 euros. Front axle brake pads, a brand, around 100 to 150 euros. Shock absorbers per axle between 200 and 400 euros. Hourly wage. Universal garage often between 60 and 100 euros per hour ex VAT. Maintenance costs. Small oil and filter service, roughly between 200 and 350 euros. Major service including more filters and control between 350 and 600 euros. Maintenance and intervals. Maintenance interval advice for this diesel. Oil and filter maximum 15,000 kilometers or 1 year. Air filter every 30,000 kilometers or sooner if clogged. Fuel filter every 60,000 kilometers. Cabin filter annually. Timing belt with water pump between 125,000 and 150,000 kilometers or 6 to 7 years, depending on factory data. Part inspection. Braking at every turn. Chassis and steering parts annually. Cooling system and belts at every turn. DP, F back pressure via diagnosis in case of complaints or during many short journeys. Average annual maintenance costs. With normal use, calculate roughly between 500 and 900 euros per year, excluding major repairs. Lifespan of parts. Average lifespan. Battery 4 to 6 years. Starter motor for 8 to 10 years. Dynamo 8 to 12 years. Turbo possible with proper maintenance, above 200,000 kilometers. Clutch often around 150,000 to 250,000 kilometers, depending on driving style. Shock absorbers around 100,000 to 150,000 kilometers. Recognition of replacement need. Difficulty starting the battery or starter motor. Whistling or whining sound with turbo pressure, turbo damage. Clutch slippage at full throttle in high gear. Approaching and pumping motion, car shock, absorbers worn out. Prevention of future problems. Maintenance measures. Always use oil of the correct specification and replace it on time. Failure to adjust the fuel filter prevents damage to the high-pressure pump and injectors. Only run the engine gently until it warms up after a few minutes of higher speed and load. After a heavy load, let the turbo run for a while by slowly coasting. Driving style. Avoid extremely short journeys. DPF cannot then regenerate properly. Occasional longer journeys on a motorway at a constant speed help keep DPF clean. No full throttle at low speeds. Avoid high torque at low speeds. Saves the turbo and clutch. Liquids and oils. Preferably use premium diesel, occasionally, to limit pollution. Change coolant and brake fluid on time according to factory schedule. If you have any doubts about the quality of the oil, change it sooner. Purchase used car. Points of attention. Check maintenance booklet and invoices. Evidence of timing belt and water pump replacement. Cold start view smoke tick. Test drive turbo pressure traction smoke image. Have error codes read before purchase. Questions for seller. When is the last major maintenance? When was the last time oil was changed? Has DPF ever been replaced or cleaned? Have your injectors or turbo been replaced? Known faults or warnings in the past? New or used parts? When new parts. For safety parts, brakes, suspension. For engine core parts, distribution, injectors, turbo preferably new or factory, overhauled. Average price difference. Used parts can be 30 to 50% cheaper. The risk of a shorter residual lifespan is higher. Engine overhaul or replacement. Benefits of overhaul. Retaining original engine. Full control over used parts. Costs are often lower than a completely new engine, but higher than a good used engine. Average costs. Complete overhaul 1.6 diesel, often between 3,000 and 5,000 euros in total. Used engine with installation roughly between 2,000 and 4,000 euros, depending on mileage and warranty. Gearbox repair or replacement. When to overhaul. If there are audible bearing noises or synchronization problems. In case of structural switching defects, without a clear external cause. Replacement costs. Manual transmission, overhauls often cost between 1,500 and 3,000 euros. Used container with mounting roughly between 1,000 and 2,000 euros. Choice of petrol or diesel. Maintenance and reliability. Diesel has more complexity. FEGR turbo high pressure injection. For many kilometers per year, diesel is more cost-effective, but maintenance is more critical. Petrol is often technically simpler and less sensitive for short journeys. Costs and risks of diesel. Higher chance of expensive items, DPF turbo injectors. It is important to point out to the customer the need for good maintenance and a driving profile that suits diesel. Summary advice for this Citroën C3 1.6 e-HDi. Recommended. Strict maintenance schedule with short oil intervals. Check status of timing belt, water pump and DPF. Read regularly and check for emerging EGR and DPF problems. In case of engine complaints, first systematically check the fuel system, turbo, EGR and DPF according to the above plan. Maintenance plan. Small service, every year or 15,000 kilometers. Major service every 2 years. Do not exceed timing belt according to time and kilometer. Proactively check turbo and injectors at high mileage. Expected annual costs. With normal use without major repairs, approximately 500 to 900 euros per year. Bearing in mind that turbo DPF and injectors may incur additional costs at higher mileage. You can immediately use this plan as a guideline in the workshop and supplement it per car with the concrete error codes, measurements, and findings during disassembly and test drive.